So potential energy. So if you look at your equations at the top, so if you work at your equations at the top, potential energy is this one, mgh. So PE equals m, which is 0.5, g, which is 9.8, h, which is 2.5. Notice I did not make it negative 9.8 because the 9.8 is just a value, it's not a direction. Okay, so it's a scalar this time, only a magnitude. So all I have to do is multiply those together, and I get 12.25. And the unit is joules. Basically, all the units are joules unless we're talking about power. Power is watts. Okay, what would the work be required to lift it to the height of the air? We've been using two equations for work, and we're not going to stop now. W equals Fd, or W equals delta E. So, write down the things that you know. We know the mass to be 0.5. We know the distance or the height. So this is in the air. So this is a height of 2.5 meters. Some people asked, is it starting at rest? Yes, you can assume that. So the V initial, if you're thinking about that, would be 0. So how much work would be required to lift it that high in the air? Well, we can use W equals Fd, or we can use W equals delta E. For this problem, the energy we're talking about changing is potential energy. So it would be PEF minus PEI. So I'm looking at this and I'm saying to myself, well, the force I'm applying is the lift force. The lift force is against gravity, like the lab we just did. So that would be mg. I know mass, g is 9.8. So F is good. The distance is how high I lift it. That's 2.5 meters. So W equals Fd will work. But so will this other one, because I just found my potential energy initial. Or, well, I guess I'm starting on the ground, and I'm lifting it to a height in the air. So I know my initial and my final potential energies, so I can use either of these equations. So I'll show it to you both ways, just to kind of point that out. So W equals Fd, you got to find the force first, which the force you're applying is the force against gravity. So you're applying a lift force. You're lifting against gravity, so they're equal. And that's just mg. Okay, the mass is 0.5. G is 9.8. So that's 4.9. So work is force times the distance. So work is equal to 4.9 times the height, which is 2.5. Gives you 12.25. Or we can use the energy change. So work is equal to final minus initial potential energies. So I end up lifting to a height of 2.5 meters in the air. So this is my final potential energy. This is how much potential energy I have, 2.5 meters in the air. So we're doing PE final minus PE initial. The PE final is 12.25, and the initial is 0 because it starts on the ground. So the height, PEI, MGH, the height would be 0 because it starts on the ground. So PEI is 0. So 12.525 minus 0 is 12.25. Yep. So I want you to see you could do it either way. Doesn't matter. Doesn't matter which way you do it. You can get the same thing. So what do you notice about your answers to A and B? Well, they're the same. And that should make sense because in order to get potential energy, you have to do work to get there. You have to do work to get potential energy. So you had to start with work and then you end up with potential energy. So the 12.25 for the work should equal the potential energy I end up with. So they're the same, and again, the reason they're the same is the potential energy is what you get after you do that much work. So after I do 12.25 joules of work, I get 12.25 joules of potential energy. So that's how that works. Okay, so I want you guys to try number 1. Okay? Bartleby, a vociferous and somewhat annoying cat, is about to sled down a hill. Assume he has a mass of 17 kilograms and starts at the top of the 7-meter hill. How much potential energy does he have? So you're just solving PE equals mgh. Then, how much work would gravity do to pull him down the hill? Ignore friction, as he's using a completely frictionless sled. So then you're going to do equal either W equals FD or W equals delta E. Don't worry about the delta KE, just make it delta E. And then the last part, E, assuming you start at rest, what would his speed be at the bottom? You can assume that the velocity at the top is 0. So see if you can figure out what his speed at the bottom is going to be. So go ahead and work on those. I'm going to be checking these at the end of the period. So get these knocked out and taken care of. Again, it's just 1 and 2 on the back. And I will see what questions you have. I'll come around and help.